I've cleaned the wound, but if you haven't had a tetanus shot lately, you may need a booster shot. Tetanus causes muscles to tighten and spasm. If it's not treated, you could have trouble speaking or even breathing. That's what makes it dangerous. It's caused by bacteria. Here, I'll show you.
The nail has introduced tetanus spores into the wound. Under conditions of low oxygen, as found in a deep puncture wound, the tetanus spores can germinate to produce living tetanus bacteria. The spores also release a toxin called tetanospasmin, which enters the bloodstream. Bacterial numbers increase as they grow and divide. Some bacterial cells develop spores at one end. The bacteria lyse, releasing these spores and more tetanospasmin toxin. Bacteria without spores can also lyse to release toxin. The toxin enters the bloodstream. Movement is enabled by skeletal muscles, and skeletal muscles are controlled by motor neurons. An electrical message is sent down the axon of a motor neuron and arrives at the terminal buds. Chemical neurotransmitters are released, which bind to the muscle fibres, causing them to contract. Shortly after, the neurotransmitters are released from the muscle fibres, allowing them to relax. Repetition of this process tells the muscle fibres to contract and relax as required. If you are infected with tetanus bacteria, the tetanospasmin toxin can reach motor neurons via the bloodstream. The toxin enters the motor neuron via the terminal buds. The toxin then travels up the axon towards the neuron cell body, which is found in the spinal cord. After 2 to 14 days, the toxin reaches the motor neuron cell body in the spinal cord. Other toxins travelling in the bloodstream also enter motor neurons and make their way to the spinal cord. We will now zoom into the spinal cord tissue. In the spinal cord, the motor neurons are controlled by inhibitory interneurons. These interneurons prevent the motor neurons from constantly firing. Tetanospasmin toxins arriving in the motor neuron cell body interfere with the action of the inhibitory interneurons. To see how the toxin exerts its effect, we will zoom in on a synapse between a motor neuron and an inhibitory interneuron. The interneurons release inhibitory neurotransmitters into the synaptic junction. These prevent the firing of motor neurons so that the muscle fibres they control do not constantly contract. Tetanospasmin toxin moves out of the motor neuron across the synapse into the inhibitory interneuron. The toxin prevents the release of inhibitory neurotransmitters from the interneuron. The interneuron can no longer control the motor neuron, so the motor neuron fires constantly. Here we see many motor neurons have lost their inhibitory control and are constantly firing. This leads to continual release of neurotransmitters from the motor neuron terminal buds, which cause the muscle fibres to contract repeatedly until spasm occurs.
If you did get tetanus, it could take months to recover, but this gamma globulin shot will protect you from the toxin. Remember, tetanus is dangerous, especially in infants and young children, so getting vaccinated and getting boosters is the safest bet.
Hope you liked our video. Share this information with your loved ones and don't forget to subscribe to our channel. Thank you.